Cool. All right. Developer joy is actually pretty scary if you see your face as blown up like this. So as developers, we actually have the best jobs in the world, right? We're just like can work from everywhere. We can create stuff. We can be very, very creative. So you might ask, why is this guy talking about like developer joy? We enjoy our work, right? And I'm enjoying my work too. And as a developer, when I started 20 years ago, yeah, sorry, I'm that old dude. So when I started 20 years ago, actually, I was super enjoying what I'm doing. So why are we talking these days about just like developer joy, right? So let me just like travel back 10 years ago, right? So the last 10 years have been pretty heavy on developers. A lot of things has actually changed in the last 10 years, how we develop software. If you look at that, so the cloud, right? So 10 years ago, well, there was no lot of cloud development. Now everyone is just like developing in the cloud for the cloud. So we need to learn some new toolings, AWS, Azure, GPD, you name it. Then also containerization. Now we have to put everything in the container, and we have to just like observe what's happening in those containers and orchestrate those containers. That means new tooling, new things to learn, all on shoulders of developers, right? So everything is new. Then home microservices. Now we just like have single responsibility, small little services that have some APIs, talk to other services. What if the service is not available? We have to handle that. And this is all making things more on the developer side. So we need to think about this too. Security and governance. We haven't really had that 10, 12 years ago when we were not thinking about security and governance. Now also we have to just like handle that as developers. How can we make our software more secure? And then the whole like, you build it, you run it, it's on your shoulders. You're not just responsible for the code, you're also responsible for the operation of the code. So all of this actually have been added to the developer's toolbox, and it actually increases the cognitive load of developers. Now we have to handle all this. We have to keep that in our heads. We have to work on that. And of course, nowadays everyone's saying, so let's talk about developer productivity, right? Be more productive. And say, yeah, but you put this all on our shoulders, and now you're saying we need to be more productive, right? We hear that all the time, just like, oh, increase your productivity. So let's travel back a bit in time. Are you with me? You want to travel back? Are you okay with that? Right? It's a little experiment, travel back. I promise you I will bring you back to 2023. So I count to 3, you watch the slides, just like concentrate on the slides, and I count to 3, and we will travel back in time. 1, 2, 3. All right, here we are. 125 years ago, right, in the Bethlehem steel factory. And at that time, the Bethlehem steel factory had a little bit of a productivity issue. They wanted to increase their productivity. Nowadays, what you do is you just like hire McKinsey or any consulting company to come in and just like improve every little thing. At that time, this was not there, so they hired one person. And the person is called Frederick Winslow Taylor. You might have heard of Frederick Winslow Taylor, famous for his Taylorism. And Frederick Winslow Taylor came in to optimize the factory, the productivity of the factory. And he looked at the factory workers, right? And then he just like said, okay, good. I'm going to measure now how fast you work, right? So he put out a stopwatch and just like measured how fast it takes to shuffle the coal, to just like walk from A to B, and just like trying something like, oh, shuffling. I see there's a lot of coal falling out of the shuffle. So we just like make custom-made shuffles. And boom, he increased the productivity of the workers, right? Just by giving them better toolings. That's not all. He also looked at when people were carrying heavy stuff, and they could carry more in the morning than in the evening. It's obvious, right? You just like get exhausted. So he said, yeah, well, I give the workers actually a little bit more breaks to just like recover a little bit, just like 15 minutes in between. and boom, he increased the productivity. So he optimized the hell out of the workers, right? So he increased productivity by 400% of the factory workers. But everything comes with a side effect, right? It's not just like, okay, we increase the productivity. Also, it did something with the workers, right? The workers are now doing only repetitive tasks. Everything is just like super organized when the workers shuffle, when they have breaks, everything is super organized. And then he invented the managers. And the managers were supposed to think. The workers were not supposed to think anymore. They were just like doing repetitive tasks, right? And the managers were just like hired to just like do the whole thinking. All right. I told you, this is 125 years ago when we were trying to optimize productivity. So, and I promise you to bring you back in time, so let's travel back again to the year 2023, and let's talk about modern jobs, like developer jobs. That's why we're all here, right? About developer productivity. How do we measure developer productivity? And actually, when I started my first job back in the days, my boss were measuring developer productivity by the lines of code we were writing, right? He was just like reporting it up and say, oh, we added 100,000 lines of code this year, great success, boom. But we all know, like, yeah, we can game that, right? We can just like write more code if we need and just like being more productive. We're not more productive by writing more lines of code. So, okay, we know that's not a good measurement for productivity. So what's next? Yeah, how much issues we have done, right? So we can just like count the number of tasks or issues we do. Also there are smaller things that we work on. There are larger things we work on. We can't really say like, is that a good measurement for our productivity? So then the next thing is like, we're just like doing story points, right? So we just like have the Fibonacci numbers, and just like say, is it a 2 or is it a 7? And then we do the task, and then it was actually planned as a 2, but turned out as being a 13 or something, right? Because things take sometimes longer, and some things take shorter. So also that didn't help actually with measuring our productivity. And then also t-shirt sizes, we came up with t-shirt sizes. It's actually easier than Fibonacci number. Who can remember the numbers anyway? So just like M, L, XL, great. Also doesn't have anything to do with productivity, right? So nowadays, we just like measure cycle time or deployment frequency, right? And then just like measure our productivity by that. And then people just like taking those numbers and say, we need to improve it. We need to improve your productivity. And we put the pressure on the developer, right? We just like put more pressure on the developer and say, increase the number of story points that you do. And review 20% more pull requests, right? And then improve the productivity. Yeah, thank you, Frederick Winslow Taylor, still for having that. So, but we all know, like, our jobs are not just like being very, very productive. We also have to be creative, right? And it's not about just like being productive. So nowadays, we talk about increasing the developer experience, right? We want to have a better experience as developers, right? And that is actually makes us productive. I don't want to rant about that, but it's fine. It's good. I love developer experience. I love the term. I love what it's all about. But all of a sudden, there are smart consultants that are doing some more frameworking on developer experience, right? So this is a thing to improve developer experience. And there are good things in there, like decreased burnout, increased team satisfaction. So it's not just about those numbers, but it's also just like what we thought at Atlassian. We can do better, right? And it's not about just like the experience that we have. So what does that mean? Is that if we shoot around with Nerf guns, is that a great experience or not, or whatever? What we think is actually the ultimate thing is we want to enjoy what we're doing. And that's why we became a developer. And we believe that when we enjoy our jobs, we are also being productive. We're also doing great things. So we divided it into 3 things to optimize, or just like to be better at, to improve our developer joy. And you will see like how that connects to just like enjoying more what we do as our developers, enjoying our craft again more. The first thing is just like the developer quality. It's obvious, right? If we work with high quality, great quality code, yeah, we enjoy what we're doing, right? Who wants to work on shitty code, right? Right, on a shitty code base? No one, actually. So we want to just like have a great quality code. So this is one thing. The next thing is just like, we want to move forward fast. We just don't want to stack, we don't want to wait on other teams, we don't want to wait on other colleagues, we want to move forward fast. If we have an idea Monday morning, we want to get it in production Thursday afternoon, right? So this is great. This is when we enjoy our work. We can move things forward fast, no roadblocks, everything is moving quickly. And the third thing is, we want to create value. We want to take pride of what we do. We want to be proud. And if a customer says, we really love your code, we really love what you're doing here, the product, we use it day in, day out, and the new feature that you implemented is great. I love it. We just like feel like, yeah, I'm totally enjoying what I'm doing, right? So improving those things brings us actually to more developer joy. So let's look into those things a little bit, and I will tell you a little bit some stories that some teams within Atlassian did to improve it. It's not the whole picture, and you will see at the end that the whole picture is up to you to complete. But I want to just give you some ideas what teams are doing to improve, actually, for first thing, the developer quality. So assume you work on a great product, right? A product that everyone likes. If they look at it, they love it, right? It's just beautiful. It's a beautiful product, right? And then some customer comes and says, Sven, can you just like this little window over there, can you just like change that? And I said, yeah, sure. Let me just like open my IDE. I just like look at the code, and the code looks like this from inside, right? We know it's crap, right? We don't want to work with that. We don't love it. We just don't enjoy it much. And I mean, this is called technical debt, right? But we all deal with technical debt. Everyone does it. In every code base, there's technical debt. No matter what you do, you will end up with technical debt. And here's some numbers. 42% of developer time is used to deal with technical debt. We did a research on that. And then also 10% of the teams are actually actively manage technical debt, right? Wow, 40% time dealt and 10% just like actively manage it. That's a little bit like a downward spiral. So we're just like going down, it's more technical debt. But we need to look at it, and we need to just like work on it constantly, and need to be consciously about it, that we have technical debt, and we need to spend time just like to improve our code base. So I wrote this great class. Well, it doesn't matter what this class is and what it does, but I wrote this great class, right? And then I just said, okay, great, like I check it in, it's working, it's putting in production, working great, and then I go on vacation, right? And then after 2 weeks of vacation, I'm totally relaxed and said, oh yeah, I want to just like look at my awesome class again. So I open my IDE, open the class, and then my coworkers have changed quite a lot in their class, right? And so actually, sometimes things end up in a mess, right? And I don't want to blame my coworkers. They didn't say, oh, well, Sven has this beautiful class, I just like, let's mess it up, right? Just like to make Sven's work worse. No, they just like said, okay, I have no time, I just like have to implement that, and that's a class, I just like open it, and it just like feels like it belongs together. But yeah, it's not good. We know that, but things happen, right? You probably have these kinds of classes too in your code base. But what you should also have is coding guidelines, right? So your coding guidelines should have caught this, right? Your coding guidelines should have caught this, right? You have coding guidelines in place, okay? Yeah. So I can just recommend, like, have coding guidelines. I know a lot of things can be done by static code analyzers. Not everything, right? And maybe ChatGPT or the new AI functions in code can just like help us with that. But you see there, that's a Bitbucket Python coding guidelines. What they have there, just a few examples here on that slide. But one is the single responsibility principle. And definitely, this was against the single responsibility principle, what my coworkers did with my code. So my coding guidelines should have caught this. So I'd say they should have done this, right? And just like write down explicitly what your coding guidelines are, or just like copy it. There are tons of examples out there in the internet, so just like copy things over, change it, and make it yours. and then agree with the team what your coding guidelines are to improve your code quality, to enjoy more the work that you're doing, right? So how do you check those things? Some stuff can be, as I said, checked with static code analyzers, and other things are caught by code reviews, right? You're doing code reviews. You're doing code reviews, right? Every line of code get reviewed? Okay, great. Just to make sure. So code reviews, but let's be honest here. Not everyone loves to do code reviews, right? Everyone loves to put out their code in front of their coworkers. And that has several reasons, right? So let's assume I have written this here, this is the new code, and then some reviewer comes in and gives me this comment here. What the fuck, Sven? So, all right, great comment, thank you very much. I'm already depressed, right? And then say, why? And then it says, you know, Sven, this code looks ugly. So, oh God, yeah. And this is actually, this is happening in real code reviews. And this is the reason why people don't like code reviews, right? Or this comment here, right? It would have been nicer if you used a for loop. Duh, why, right? Why? I think the while loop works great, but hey, what would be nicer? So, just like 4 words here. Don't be a jerk, right? If you do code reviews. So, quick questions. Who actually has been bullied by a jerk, let's say in the last 2 months here? Hands up. A few? Yeah, I know your coworkers are in the room, so you don't have to do that. It's fine, right? So, but actually, jerks are the reason why people hate code reviews, why we don't like code reviews, right? Because people are just like mean with doing code reviews, and this is just like also, this is why we don't really like code reviews. It's okay, but our code just like got reviewed. You need to see it like this, right? You are, as a reviewer, in this protected bubble, right? And then, but you as an author open yourself up, right? You open yourself up, you're vulnerable, your code gets out there, you get comments on the code, and this is pretty hard, right? This is super hard. So just like also here, have some rules if you just like do code reviews, like assume competence, right? Assume that the author is competent of doing things. Be constructive in your feedback, right? Don't say like, what the fuck, Sven, this code looks ugly. And just like explain the reasoning. Why is a for loop better than a while loop, right? I want to learn. I want to just like also learn from this code review and improve your code reviews. Okay, now we have reviewed the code, everything's great, everyone accepted, and then I just like merge the pull request back into the code base, and what happens next is that a test kicks off, right? And then the test runs, or the build runs, and the test runs, and then all of a sudden the test turns just like red. So, oh, okay, things happen. So I go back to my IDE and just like look, okay, what did I change? What does the test say? And then it's like, what did I change? I don't know. I don't know why the test failed, actually. What do I do next? What do I do next? I rerun the test, right? Sure, yeah. I rerun the test, and boom, green. I can go move on. Oh, no, shitty. I just have detected a flaky test here, right? Oh, it's time for a commercial, sorry. We'll be back in a few minutes, time for a short commercial here.
Is seeing red build after red build getting old? Is rerunning your failed jobs getting you down? Is waiting on those failed jobs to finish making you crazy? Deterministic Reliability is here to help. With our handy-dandy flaky test monitoring system, we will, eventually, automatically bypass those flaky tests. For 4 easy payments of free, you too can save time, ship quality code faster, be more productive, feel so much better when you go to work every day. You will be happier, your team will be happier, you'll stop dying inside, you'll stop banging your head against your desk, you'll stop replacing computers that are in a rage against the wall. Sorry. It's just a little close to home. Call 1-800-Atlassian today to get your free flake monitoring system.
Okay, please don't call. It's of course no new tool from Atlassian that we offer. It's just a video that one team did. They built this flaky test detector, right? And they put out this video. So what does it do? Once you create the pull request, then of course the build and test phase starts, kicks off, the build fails, the flaky test detector reruns the test passes, boom, flaky test detected, right? Then it marks the test as skipped because it's flaky and we don't want to just like stop working, right? But it also adds a comment to the pull request, right? And not only that, it also gives you a Slack message in the team chat to just like look at it, and then you can work on it and fix the flaky test, or maybe the code is even flaky. So just like look at that. But now we talked about quality, code quality, how to improve code quality, a little bit like what is actually great developer quality, right? What is the good quality? If you have no idea, it's a good way to start with the DORA metrics. So just like do change failure rate, so how much is the ratio between success deployment and failed deployment, or the time it takes to just like from failure to improve your, to just like have a successful deployment again. So these are the DORA metrics. And if you just like, I think it was 2017 or around when they came up, when they put it out, there's a lot of research behind the DORA metrics that improves actually, or high performance teams are actually scaling high on the DORA metrics. So measure it over time, but also not just like measure it and say, oh, the number is 20. That doesn't tell us anything, right? But also put on baselines, non-negotiable baselines, right? So just like having a baseline said, if I crash a baseline, I have to do something. Put it maybe on a wallboard, right? Like this here. But then there is this whole wallboard problem where if just like one thing is red, yeah, you maybe want to fix it. But if everything is here red, you just like ignore it, right? You just like say, okay, that's too much work. I don't want to work on it anymore. So what we do is not just like putting it on a wallboard and everyone can look at it. We're also just like doing a ritual called CheckOps. We're using our own tool, Compass, for this. So in Compass, you can just like see all the measurements, but you can also write down as a team, just like what are we doing. So it shows you the whole metrics, and then if you just like crosses a baseline that you have set yourself, it just like turns red, and then you can just like as a team write down all the actions that you want to do as a check-up ritual and run this on a weekly basis to look at it next week and improve things. So quality metrics on one side, but then also important baselines on the other side. So here's some other stuff that we are tracking, but if you start with things, right? Just like start with just like 2 metrics and try to improve those. Don't put too many metrics out there, then you will just like have a red board and it's just like too much information and too much things you want to improve at the same time. To move forward fast, you want to improve also your developer progress. So let's talk about developer progress, how we can just like get more stuff done, right? So just like, or more in the flow, right? So who has been here in the last 2 weeks in the status meeting? It's like, oh, wow. Yeah, most of you. Yeah, great, right? Okay, hands up. Who enjoyed it? 1, 2, great for you, great for you. More status meetings next week, right, for you. For the rest of us, it was just like, yeah, status meeting could have been a page, could have been just like an email. I don't know, right? But it's just like interrupting us in our workflow, these whole like meetings. And who actually here has been interrupted during programming time? Just like deep down programming time here, and someone came, and then, yeah, this message. Hey, do you have time, dude? Oh, yeah, out of the flow, right? But flow is so important, right? When we code, just like we want to get into flow, we get more done. We have maybe also our special keyboards that get us more stuff done. Great. So code phase, pretty much important that the work flows. But then there's more to this whole software development lifecycle, right? Like the build and test phase and the deploy phase. And yeah, we can also optimize that. Maybe build and test takes hours to maybe minutes, or deploy phase minutes to seconds. And we can optimize the hell out of that by running tests in parallel and all those things. Great, great, great. So we can optimize the time from coding to deploying. But what takes most of the time is this phase here, right? And we talked about it already. The review phase, right, can take days, right? So Actually, one team at Atlassian measured that over time, like how long is the time where I just like put on a pull request and then I merged it back into the code base. And they found out this here, 3 days average, right? From opening to merge a pull request, 3 days on average. I think it's pretty much standard, right? It was standard within Atlassian when I asked around. So it means 3 days of working on something else, and then someone said, oh, I don't like that, and then you come back and you have to just like shift your mind again to the code that you have been written 3 days ago. So we need to shorten that time also to put features faster into deployment, right? So one team at Atlassian had that, right? Open pull request, 3 open pull requests, and then it took 3 days. But then the team lead jumped in and said, you know, every morning what I'm doing is I'm gonna open my Slack, I'm gonna look at the pull request, and I'm gonna ping everyone here, Punit, right? Punit, ping everyone to just like work on the pull request. And the people just like said, oh yeah, I got this notification, but I forgot about it. So fair enough, just like, it's just a short nudge, right? Of course, and this helped, and actually, it's just like a repetitive work, and what are we doing with repetitive work? So at a small hackathon, the team just like rewrote Punit to a Punit bot that is now doing the work, right? So now Punit is not out of work, he still has some other tasks to do, but so the Punit bot is now pinging everyone in the morning, just like saying, okay, you have an open pull request, please work on that. And they actually cut down the pull request time from 3 days to 1.2 days. That's pretty significant, right? Because it improves the flow, how things flow through our workflow. And I'm just like obsessed with flow. I want to find out what is the best method of flow. And then I looked at traffic. So there are some traffic simulations here. So a junction, no rules at all, just like totally chaos here, right? And the traffic flow here is, on the simulation, is 191 cars per hour can pass this traffic junction. Great. So let's put in some rules here, like chaotic, maybe not the best way to just like do this junctions. Let's put in some rules and put in some traffic lights. So some cars can speed through the junction and other cars have to stop and wait until it's their turn. So we all know that traffic junction with traffic lights, you see like it's moving faster and then the other lane is moving faster. And the traffic flow here is actually 235. 235 cars can pass that. But if we just like translate this into software development, we don't want to wait just like until we have time to do some other stuff or just like some other team has just done something. We just like want to get in the flow, right? And the best way of getting in the flow is a roundabout, right? So you see like if once there's a gap, the car gets into it. So if the designers have a gap, we can just like get the designs into this. And you might also saw that they have this fast lane here. So there's a car just like fast. So we also can just like exploit something if there's a bug or something. Great. So the traffic flow here is 360. Great. From 190 to 360. Great improvement. But that's not the best thing, right? The best thing in traffic is this, a stack interchange. And you see no car is stopping at all, even not slowing down. They are just like merging into each other, right? So they're merging the lanes and they're merging it into each other. So traffic flow here is 1,099 cars per hour. It's just like amazing, right? So let's build that into our software development flow. How do we do that, right? That we can just like flow and don't stop at all. We do that by building autonomous teams. Teams that are just like owning the whole process, right? And that might sound a little bit chaotic, right? So, and you see like the lines are also showing this, but we need to align those. So it's autonomous teams highly aligned. But what does autonomous teams mean, right? That the team is responsible for all kinds of tasks in the development lifecycle. So developers are doing designs. We have a design system where developers can just like use design. Developers are doing ops. We talked about that, right? We own our code also in production. And then developers are also testing their own code, right? Well, it's a lot. We talked about cognitive load, right? So this seems to be more cognitive load on the shoulders of developers. And the Trello team had this problem. In the good old days, right, the developers were doing developing. The QA team was just like, we throw things over the wall and get things back from the QA team, right? Until then, the developers took over of all of it, right? Doing the manual test and also the whole like automated test. I mean, we're writing automated tests, sure, but also the whole platform on building automated tests and test databases and so on. So QA department is now drinking pina colada on a small island somewhere, and because the developers are taking over all the jobs, and we don't have a QA person for every team, right? So how can we do that? So and the Trello team, they established something they call quality assistance instead of quality assurance, right? So these people are actually helping developers to become better testers. So they're helping them with the manual test and with the automated test. How does that work? So if you start a feature, you just like get a QA engineer, so a quality assistance engineer, and you're doing, before you start developing the feature, you're just like building a test list, a manual test list, how you would test this feature, right? And you're just like writing this down together with a QA engineer, and you learn a lot about just like how QA engineers think. So at the end, once you just like have done your feature, right, you just like go through the test list. You don't need the QA engineer anymore. And this way, the work flows through the pipeline. Or test automation. So we have a lot of software engineers on test, right? They're working on the QA department, and they're building all the test toolings, the test databases, so the developers can just use that in their daily work, right, and don't have to think about it, and just like ask them to build it. So all of this, just like, first, the developer flow increases because the developers are doing the work, but at the same time, the cognitive load decreases because they just like, they get assistance by the QA, the quality assistance people. All right. Also, what we like as developers to just like get more flow or get more things done is new technologies, right? We know that. Just like we get a new programming language, we're getting excited about it, we said we can be more productive, we can write features with it because everything is more simple and going faster. That's also what the Bitbucket team thought when they used Scala 10 years ago. So the Bitbucket server team thought, we're building everything in Scala, right? We're building our Bitbucket server in Scala. They started with it, they loved it, they enjoyed it, until the day when they broke up with Scala because the compiling took so long. All of a sudden, they had a big code base and compiling took so long. They had really problem finding people understanding Scala to add to the team because the team needed to grow. So most of the code nowadays is rewritten in Java, actually, because they just like thought this is better. Said that is, it's great if teams experiment, but putting in production can be, and that's why, actually, I'm a fan of just like a standard way of developing software. If your company is small and you're just like 10 developers, fuck it, doesn't matter. But if you're just like a bigger company, hundreds of developers, or maybe even just like 60 developers, you probably want to have a tech stack, right? And it's more like an opinionated way of developing software, and I come back to that a little bit and a bit, just like what that means, right? Because it is a defined tech stack, and it makes things easier, actually. It is a defined way, right, for new engineers to jump on it. It's just like a specific set, and if you heard the term platform engineering and building developer platforms, this is what the developer platform does. It just like gives you easy access to these technologies, spins it up for you, configures it for you automatically. You can do it through APIs. So this is what the developer and platform team takes care of. And then flexible project teams. Imagine you just like have to shift teams or even products, and then you need to learn a whole new tech stack. This is just like super hard. But if you just like have the similar tech stack, not the same, the similar tech stack, it's easier to move between teams. And also helps to tame the whole software sprawl. You know, you have some old technology that you just like used in, I don't know, one team just used or something. You still have to maintain that. You still have to update it. So have a defined tech stack if you're a larger team. But that means less flexibility, right? Yes, but there's still a way here innovate, right? You can still innovate and you can still try something out. And if you think this technology is something that should be on the platform, you can ask the platform team to put it on the platform. But also, so freedom to pick whatever works for you should still be possible to do that, but have the responsibility to maintain it long term and not just like throw it in, but maintain it long term. And you are responsible for it. If it's not on the platform, you as a team are responsible for it to maintain it long term. It's just a conscious decision that you do and not just like throwing everything in, but just like a conscious decision that you just like now, okay, we have to maintain that now probably for years. Because it's on the platform. And you think like, oh, that sounds like a big bank or big insurance, not very innovative companies. Basically, these companies have coined the term, actually. So Netflix called it the paved road, and Spotify calls it the golden path. So they have these platforms too, these tech stacks too, that they use internally. And it's not only the tech stack, there's much more on their platforms, like test tools, alerting, CI/CD, you name it. All is also working on the platform. So it lowers the cognitive load of developers if the platform team can just like host most of the stuff. Okay, we talked about developer progress, like what is great developer progress and how do we measure developer progress, right? Also here, the DORA metrics are probably a good start, right? So you can start with the DORA metrics like deployment frequency, like how often do you deploy, and then also lead time for changes, right? How long does it take from commit to production, right? We talked about this. So this is a good start if you want to just like try to have some signals how good you are. Set baselines, check the baselines with checkups, and then you're probably good. It's a good start. But we love to just like move things forward, right? We love to have great developer progress. But then there's this other side, right? We need to just like also working on keeping the lights on, right? Things are happening. We need to also work on this. What's a good ratio? And do you know your ratio, how much time you spend on just like developer progress and keeping the lights on? And we wanted to find it out, like, what does great teams, if we have great teams within Atlassian, that's like, what does that look like? Like high-performance teams compared to some medium teams, right? What does that look like? How much time do they spend on these things? And of course, we needed to define first what does progress mean and what does keeping the lights on mean. So progress for us is actually working on internal and customer improvements. So feature development, if we work on that, that's progress for us. Working on organizational development, so if you're doing job interviews with new candidates, right, this is moving things forward, this is improving, so this is also for us, developer progress, and also innovation time, just like spend time on innovative things, just like innovative projects also. This is also helping us to move things forward, and this is also what we just like calculating into developer progress. Keeping the lights on, reducing entropy, so right? If something happening, just like we need to jump on it, if there's a bug, right? We need to jump on it, and reducing that is just like helping to keeping the lights on. If the service is down, we need to work on that. Service operations, so everything that is running, just if we need to just like improve that or update some stuff. This is all about keeping the lights on, and also administrative time, so meetings, right? This is all keeping the lights on. So, and we look now, as I said, on how much time do you spend on one side or the other. And what we found out is that really great performing teams spending more time than 60% on progress and less than 40% on keeping the lights on. And we just like encourage developers to just like measure it, maybe for a week or so, just like write it down, how much time you spend, and then reflect yourself where should we improve, right? And talk about it as a team. And it's not only just like good to have the number out there. What we also found out, that's a great mechanism for self-reflection of developers, and said, oh, yeah, it's a great way. It's just like I should spend more time on just like progress, or just like I'm good with that, and just like reflect how much time these developers use on what, right? So just like writing this down helped them a lot. So we talked about quality, we talked about progress, but to be honest, it's not everything, right? Great quality product, Google Glasses. Great progress, they put it to market pretty fast. But was it a success? Not really, right? I saw a few people running around with it at conferences, but then it disappeared slowly. So let's talk about creating value for our for our customers, right? So creating developer value. Assume you just like have this task: deliver food to this house, and I must say it's probably somewhere in the countryside, and probably the problem is delivering food frequently to that house. I'm building a road, right? But if I don't see what the whole picture, right, I could make false assumption here. So building a road, probably not the best solution for this, right? And we don't have sometimes the whole picture, but it's so important that you just like have everything in the software development lifecycle, so from the idea to running the software, to get the whole picture of what you're building. We're concentrating a lot on the coding phase, but not too much on the idea phase or on the delivery phase. So the make phase, of course, yeah, we're writing code, we're coders, yeah, great, we're programmers, great. We spend a lot of time on the make phase. But there's more, right? As I said, the wonder phase, right, where the problem occurs, or explore phase, where we just like explore new solutions. And then also the impact phase, right? So we have defined that phases within Atlassian, and it looks a little bit waterfallish, right? Like a waterfall process, but everything is interconnected, and maybe it's also a waterfallish process. But when we look at that, you just like developers spend probably most of the time in the create phase, a little bit in the wonder phase. There we have product managers and designers that are doing more work here, and then it's falling down at the measure impact phase. That's also more product managers that just like looking at how is this product being used or this feature being used. So it's probably looked like this. But what we want, how do we make sure now that we are involved in every phase? Because we want to involve everyone in every phase here, right? So we have defined check-ins. So milestones, if you want to put it that way, but for us it's check-ins, like we're doing a project kickoff for the wonder phase, right? If the product managers has a great idea, work on an idea, they're inviting everyone, so you know what's coming in the next 2-3 weeks or 4 months or whatever. You know that this project is coming. It's not just like coming as a surprise. And you know why they are building it. The problem is defined pretty well in the wonder phase. Then at the explore phase, you're building prototypes, and it's not just paper prototypes that maybe the product managers build, but it's also real prototypes that the developers help building. And maybe they find out that, okay, what you want to build is technically really complicated, it takes a long time. If we cut it here, actually, we can be faster to do it. And then you have a great discussion with the product people, and you just don't build everything that they want, right? And then there's the make phase. So we're doing regular demos in the make phase. The developers are doing demos and demoing the software. And then in the impact phase, we're just like doing goal signal measures. So we just like measure everything, and then we feed that back to the product managers and can improve stuff. So also this is super important for us, these 3 phases. So let's look at one of these, and this is just the demo phase because we are mostly involved as developers in this demo phase, right? So running demos, we invite actually everyone, so it's like sprint demos. They are open. So everyone in the company can join. We record them, we put them out there, so everyone in the company can access them and see what we are building and why we are building it. And this is also important. When we talk about what we see, it's more about the outcome. So we don't talk about implementation details. We talk about the outcome and talk about the customer value that we're creating and how we can improve that, right? And then it's a group thinking, and we challenge the solution that we see. It's not just like we talk about how we can actually make things better, and then also it's about celebrating, right? If we did a milestone, we have just like did something great. It's all about celebrating and enjoying what we're doing, right? Because this is it, right? We want to create joy, right? We want to have fun. We want to create developer joy. So I talked a lot about just like what we did, how we do things, how we try to bring more our quality, progress, and value up. And I talked about measurements. And there's this quote from actually Peter Drucker, and you probably heard it. If you can't measure it, you can't improve it, right? So we need to measure to improve things. Sure, right? And I talk to you about it. It's like this. We have the Compass tool out there, Atlassian Compass, where we just like measure things in scorecards, where we do baselining, so it tells us if we reach a baseline, and then we're doing checkups to improve things. So you can use that, but that's not all, right? If we measure and improving and measure and improving, I already said like maybe that's not the only thing. So GitHub did an interesting experiment. They asked their developers, actually, how productive were you today? So at the end of each day, they asked the developers, how productive have you been, right? So, and the developers, yeah, some days we are more productive than other days, sure, right? And then they just like said, okay, let's correlate that with the data that we measure, right? And let's put that on that and see like if there's a correlation. All right, let's measure it, and boom. There's no correlation between the data. As we can't see, if developers feel productive, we can't see that in the data, actually. Yeah, sad Octocat, right? And it's, sometimes we're trying to treat software like this here. Like a production line, car production line, goes back to Frederick Winslow Taylor, where we just like optimize the code phase, the review phase, the deploy phase, everything just like needs to be optimized. But to be honest, we don't create cars, right? Cars, every time it's a repetitive thing. We build the same car over and over again. Software is different, right? We build different features all the time. We can't actually treat software development like a production line, even though if people want to try it and tell you you should do it, right? It's not a production line. We need to be creative in writing code. We need to be creative in finding solutions for the customers. So software development is not a production line, right? Here's another quote. Measure what is important, but don't make important what you can measure. Very important, right? So instead of just like gathering around the metrics and just like trying to optimize that, what we should do actually is just like take this metrics, but put that on the outside and trying to see what we can do as developers. What can we do better? And if you can measure everything, but if you ask your developers, what's wrong, right? They probably have the answer, right? And you don't have to look at a dashboard. You can simply ask your developers, right? So we looked also at this at Atlassian and looked at how can we involve the developers more here? How can we just like ask the developers to just like get data out that? So we developed a survey, right? And this is asking some questions here to the developers, and we ask these questions regularly to developers. The first thing is just like, are you satisfied? Are you satisfied with speed to ship quality code sustainably, right? Are you satisfied with that? Are you satisfied with the waiting time, right? Waiting on builds to do, waiting on tests, whatever, right? Are you satisfied with that? What is with your execution independence, right? Do you rely a lot on other teams to just like wait until their work is finished? Access to tools. How's your access to tools processes, right? Do you have the best tools that can do your job? Are you satisfied with managing external standards, so security and governance? Are you satisfied with that? Managing your code, your pipeline, your infrastructure. Are you all right with that? Are you satisfied with that? What about the ramp-up time? If you add new people to your team, right? Do you like the ramp-up time? Are you satisfied with that? And then, of course, the biggest question is, what was the developer satisfaction overall, right? And so we're asking these questions and say, yeah, how satisfied are you? But not every team is so every team is the same. Every team is actually different, and some teams ramp-up time is super important, and for other teams are not, right? So we also ask, like, how important is that for your team? And then we put the results on an XY scale and have defined this corridor where we think like, okay, that seems to be okay, right? But if you're just like falling a little bit low, we turn things into yellow. And if you just like fall out of the corridor, things are red. And this is indicating that you have to do something. So if you want to try that out, I put out a type form. You can try it out yourself and measure your own developer joy if you want on that type form. I also have the URL at the end. So if you don't catch that now, you can catch that later, right? So teams actually need to work on these things. They try to fix things. It's not just like there's a team that helps you, that just like tells you what to do, but you have to do it yourself. You have to just like make your work more enjoyable. So you can see the results and you can just like see, okay, we need to improve this or that, right? And then also spread the learnings. You're not alone. You probably have more teams within your organization, more other teams, right? You're running autonomously, but that doesn't mean that you don't spread your knowledge. You saw what the flaky test detector team did, right? They did a video, very funny, spread within Atlassian, everyone loves it. Maybe more teams are now using a flaky test detector. Or the Punit bot. So they wrote a blog post here about the Punit bot, right? So talked about their experience, why this is important, what they did, and put that out. And people read that, they liked that, they really enjoyed it. So spread your knowledge. All right. So 2 things, right? We saw measurements are probably giving you signals to what you can improve, right? And giving you just like more outcome-oriented signals. But also important is like survey results. Just like ask your developers, what is bothering you? Just like talk about it. Talk about improvement. Give them time to improve things, right? Give those results to your autonomous teams, right? They can fix things, and then they try to fix things, and then they can improve their developer quality, developer progress, and developer value. And I always wanted to do a Venn diagram in a talk, and now I did it. Great. So in the middle is actually, when everything is fine, everything is great, there's actually where we think developer joy lays, where we enjoy what we're doing. If these things are intact, we think like, yeah, we enjoy our craft again, we enjoy what you're doing. So work on your developer joy, right? But don't forget to have fun. That's why we all became developers, right? We want to have fun creating great stuff. Thank you very much.